Unit 2.5, perpendicular lines. Perpendicular lines. The symbol for perpendicular is an upside down T. This is something you've been exposed to in the past also. Perpendicular lines are two lines that intersect. That means they hit each other. To form equal adjacent, to form equal adjacent 90-degree angles. Now, you may in your mind say, well, they hit at 90, and that's probably fine. Two lines that hit at 90, or two segments that hit at 90, or two planes that hit at 90. But perpendicular lines are two lines then that intersect to form equal adjacent 90-degree angles. Now, if we actually had lines, then they would go forever, you see. And if this angle right here is 90, then the one beside it's got to be 90 because a straight angle is 180 degrees, you see. And these two angles are angles in the same plane with a common vertex and a common side and no common interior points, so they're adjacent angles, see? So when two lines are perpendicular, they form equal adjacent 90-degree angles. See, they're even 90-degree angles down there also, see? So what do we get out of that? Why did we say all of that? Why didn't we just say, oh, they hit at 90? Well, because we get more out of it than they hit at 90. Not only do we get that they hit at 90, we also get that they're equal, right? If CD is perpendicular to AB, I could say that angle 1 is equal to angle 2. Reason, definition of perpendicular lines, you see. Or I could say that angle 1 is equal to 90 degrees. Reason, definition of perpendicular lines. Or I could say that angle 2 is equal to 90 degrees. Reason, there's the word and what you get out of it. Or here's the word and what you get out of it. Or here's the word and what you get out of it. Any of those, we could use the reason definition of perpendicular. So given the word perpendicular, and the angles are equal, we can use definition of perpendicular. Are given the perpendicular and that an angle is 90, we use definition of perpendicular. So it's better memorized as two lines that intersect to form equal adjacent 90-degree angles. Any questions on that? Again, when you have the word and what you get out of it, your reason is definition of whatever that word is. Okay? So here's the daily work. It says given that AZ is perpendicular to PH, given that AZ is perpendicular to PH, what can we conclude from that? Well, we can conclude that angle AHP is equal to angle ZHP, and that each of those two angles, angle AHP and angle ZHP, is 90 degrees. Now it's asking here for angle XHP, X to H to P is this one. All the way here is 90. That much of it is 40. So what's left when you take 40 out of 90 is that angle, which would be 50 degrees, right? And then you could figure the rest of them out from there, you see. Now, it says justify each of these statements with a reason using the diagram above. So we're back to that same diagram. It says if. Now, that's like saying given that, right? AZ is perpendicular to PH, and what I would do is mark it in my diagram. Given that these are perpendicular, I know that I can conclude that that's 90. Reason, definition of perpendicular. This is 90. Reason, definition of perpendicular. Or I could say that this angle is equal to this angle. Reason, definition of perpendicular. So I can say if those are perpendicular, then angle AHP is 90 degrees. Reason, definition of perpendicular. I say definition of because there's the word and there's the what you get out of it. Any questions on that? Now, number 7, and I'm going to hint at you here a little bit. Right here, we're going to have the what you get out of it. And right here, we're going to have the word. Now, when it's the word and what you get out of it, you can say definition of. Well, the other's true also. If you have the what you get out of it first and then the word, you can still say definition of. So if you have the word and then what you get out of it, you can say definition of. Or if you have the what you get out of it, then you can conclude the word from definition of. Okay? Any questions on that? And we're going to let you dig around on most of the rest of those because you just need the practice. Okay? So we'll go to the next page, take a little peek at some of that stuff. Let's just look at number 14. It says ray OZ bisects angle POU. If that's true, then we can conclude that this angle 1 and this angle 2 are equal. We would put little arcs to show that, right? So we can then say that angle 1 is equal to angle 2. There's the word angle bisector. There's the what you get out of it. So the reason is definition of angle bisector. Okay. Now don't forget there's the definition of an angle bisector, and then there's the angle bisector theorem. There's definition of the other stuff. You got it? Okay. All right. Let's look at this proof right here. More experience in proof stuff. Remember, we're going to write the given proof, put the statements on the left, reasons on the right, draw the diagram. That's all done, you can see. And then we're going to take what we're given. We're going to mark it in the diagram. Ray BD bisects angle ABC. That's that straight angle. An angle bisector, by definition, divides an angle into two equal adjacent angles. So from the definition of an angle bisector, we can conclude that angle 1 must be equal to angle 2. And the reason we have the word angle bisector and the what we get out of it, two equal angles, and so we say definition of an angle bisector. And we know that if we're going to have the word in what we get out of it, we must have the word. And so we would need to put the given statement, ray BD bisects angle ABC before we have the what the word, the reason definition of, so that was given. Now we've taken the given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the notes section, and now we go to the statements and start trying to give reasons. We look at the first statement. The first place we look for a reason is given because we don't want to try to figure it out when it's given. And we always look at the diagram second because sometimes there's things we see in the picture that we couldn't get from a statement above, and you could study forever those statements above and never figure it out because it's in the pictures, you see. So angle 1 plus angle 2 is equal to 180. We look in the given and it's not there, so we move on to the diagram. And we know that those add up to 180 because we know they are a linear pair. Together they make a straight line. We could say definition of a straight angle. That's acceptable to me, and I know a lot of textbooks and a lot of instructors would also be okay with definition of a linear pair because you see with your eyeballs in the picture that they're a linear pair. So definition of a straight angle, or also acceptable to lots is definition of a linear pair. Generally, when I say definition of linear pair, I want the word linear pair and what you get out of it, although I realize you can see that in the picture. What you really saw in the picture is the straight angle, which takes you to the 180. Then you say, well, those are 180, whatever. But anyway, that's fine. All right. Angle 1 equal angle 2. Well, you go to the given and it's not there. So you go to the diagram and it's marked. Well, if it's marked in the diagram, you must have written a reason down here in the note section, and there it is, definition of an angle bisector. See? Now, the next statement says 2 times angle 1 equal 180, and you look in the given, and it's not there, and you go to the diagram, and it's not there, and you go to the note section, and it's not there, so you must have to get it by comparing the statements above to it. And so now we go to comparing statements, and we say, well, how does this look like the things above it? Well, there's the equal 180, and there's an equal 180, so that looks kind of like it. That's how they're alike. Well, how are they different? Well, this one has angle 1 plus angle 2, and this one has two angle 1s. Now, to go from an angle 1 and an angle 2 to two angle 1s, we must have replaced that angle 2 with an angle 1. And to be able to replace angle 2 with something, we have to replace it with what it's equal to. So because angle 2 is equal to angle 1, I could replace the angle 2 with angle 1, and that would give me two angle 1s by substitution. Property of equality. And then we go to the next statement, and it says angle 1 equal 90, and you may go, well, where'd that come from? There's a 90 here, and I don't see a 90 there. And there's an angle 1 here, and there's an angle 1. Oh, okay. We got two angle 1s, and all of a sudden we have one angle 1. Now, how can we go from two angle 1s to one angle 1? How can we go from 180 to 90? Well, you probably figured that out, but let's just say you didn't. Let's clear the table here a little. It's getting a little kind of congested. So you might say, well, what happened was we got the junk off of the angle 1. The junk on it was multiplication. What undoes multiplication is division. We divided both sides by 2 to undo multiplication. So this is a result of having divided. It's a result of the division property of equality. And then we get to the final statement. DB is perpendicular to AC. Now, that's never going to be in the given. If it was given what you're trying to prove, you wouldn't have anything to prove. If you already know what you're trying to figure out, don't be trying to figure it out. You already know it, you see. And it's not going to be in the diagram, because if it is, you don't need a proof either. You can just look at the diagram and say, oh, I already know that. I don't have to prove anything. I can see that it's true in the picture. So we're always going to find the last reason in the statements above it. It says DB is perpendicular to AC, and then it says angle 1 equal 90. Now, that's kind of the what you get out of it before the word, isn't it? Angle 1 is equal to 90 degrees. If angle 1 is 90, we can conclude that those must be perpendicular because perpendicular lines form equal adjacent 90-degree angles. So here's the what you get out of perpendicular. Here's the word perpendicular. And so we say definition of perpendicular. Remember, we can say definition of if we have the word and conclude the what we get out of it, or if we have the what we get out of it and use that to conclude the word. Okay? Any questions on that? Okay? And so that concluded